Hey, welcome back to the shop. We're getting started on part 2 of this little video. This isn't going to be much of an introduction, but hey, it is what it is. Now, one of the things that where we're going to be at is when I welded this, the rig I used to hold it square worked great. But how I welded this, I should have turned this and put a really big bevel on the inside of this on one side or the other, because when I welded this, I ran into, or when I was machining it, I didn't have 100% penetration. And that's one of the things that I ended up having to take and re-weld this. It caused me great pain and anxiety to have to re-weld this. So if you build one of these, put a big bevel to where you get 100% penetration all the way through this flange. Even if you blow out the backside, you can always clean up, weld and grind, and weld or turn it off or grind it off. But you want 100% penetration on this and this. So anyway, follow along and let's get going. So here's my setup for boring these holes out, and I've got my coax in there, and I'm just running her to show off how good I am with the coax and getting everything lined up. But anyway, it's lined up about as good as it's going to get, and I'm going to put the boring head in it. Now I've got a snap gauge set. My target is, I'm going to try to bore these to about 1 inch 702, 704. And I've got a snap gauge set to 1 inch 675. And when this snap gauge gets close to falling in the hole, I know to slow down and actually start measuring where I'm at. That way I don't overshoot. Not that I would ever overshoot anything. So this is my setup that I use for using a bore gauge, snap gauge, whatever you want to call it. I ended up with about 706 thousandths, which is close enough. I was aiming for 705 to 703 to 705. 706 is close enough. So there you go. And all that is just a spring clamp on a piece of plywood laying on my work cart, clamping down my cheap micrometer. And you know, everybody gets real stinky about, oh, got to have a Mezzotoyo micrometer or a Starrett or a Brown and Sharp, or, you know, if you're doing precision work, especially in a 3-man shop or a 5-man shop, and you got one man making a shaft and you're making a bearing for it, yeah, you need a very good and very precise micrometer. But even a crappy micrometer is going to have repeatability. I mean, you just can't help for it to not have repeatability. So if you're measuring a shaft with the same micrometer that you're measuring your bore gauge with, you're probably going to get reasonable results every time. Now, if you're using different mics to make different measurements, probably not going to get the exact same result every time. That's just my 2 cents worth. Okay, I goofed up a little bit. I don't know how I did it, but I got one of my blocks almost exactly 20 thousandths taller than the other block. And I kind of noticed this earlier, but I thought I could let it slide. But when you bolt it down to the base plate, it binds up on the spindle. So I'm going to have to deck these back off. I've just got my spindle in there to align it, because that's the only thing that I care about is the spindle bore. I don't care about anything else. I don't even care if it's running downhill a couple of thousandths. I just want the spindle bore through the holes and then the bottom of it flat. All I care about. So we're going to deck her off. that's got her. Got an easy sliding fit back and forth, which wanted that. Got a very nice Spinamajig fit. I mean, that's what we're aiming for the whole time. And that's, the bearing blocks are just fastened to this base plate by some quarter 20 machine screws, flathead machine screws. So I do have a little bit of adjustment and give in there. And I just happen to have flathead machine screws laying in my tool or my bolt bin instead of socket head cap screws. I like it. Whee! So we're about in the home stretch now, which is the place where I really like to screw things up and scrap parts. So I've drilled off camera. I've drilled for my mounting holes, countersunk those, or chamfered them. I finally countersunk and went to town and got me the proper flathead screws so that I've got a nice flat surface here. I have drilled an 1/8 inch through hole and a 3/8 inch counterbore about 5/8 deep for an oil reservoir. And what I'm doing now is making me some little filters to put in the bottom there. I could use like 1/4 inch ball oilers, but those cost money, and I've got a pile of these old diapers. So all it is take a gasket punch a hole out, get you some little round circles of material, stuff them down in the hole, and you end up with something that looks kind of like that, and that'll just keep out the dirt and stuff and let me dribble in a little oil. Now this thing will be covered in cutting oil or WD-40 or whatever I'm using that day, but I don't think it'll hurt to put a little extra oil in them every time I use it. So here's my indexing pin, and all this is a piece of 3/8 threaded rod stock. And I turned this down a little smaller, 1/4 inch, knocked the threads off this end and slotted in a screwdriver slot in case it gets stuck. The way I generated the hole was I just stood this up, took transfer punch, stuck it through one of the holes, about halfway in between this bore here and then the oil bore, punched it, and then drilled it out. So this goes, that thread's in, and that's what we'll index against. So I've got her mounted up here on the mill, and I have taken 20 thousandths off of this pad right here on my bottom saddle, and that'll facilitate the clamp. You know, I can put a stud in here and clamp that down, and that'll lock the spindle, I hope. So that's my plan. Get her put together here, and I'm gonna goof around a little bit with it, and we'll be back. So here's the end of it. Finished product, as they say. Works pretty good. I've already made me a square-headed nut, 3/4 inch square-headed nut, and that's my lock. So this is how this thing works. So we're going to do a four flats. It does have a little bit of play in it, but that's fine. I don't care. I could make that pin just a hair bigger. Actually, I'd put a bit of a taper on that pin. I could run that pin out just a little bit more and take that backlash out of it, but it's no big deal. I just rotate it forwards, lock it in place. That 20 thousandths clearance in between the two halves of the bearing blocks over here, perfect. Gives me a good lock. So You know, index it, slide it forward on the pin, take up the backlash, lock her down. Mill it, index it. Works great. So unlock, index, slide it up on the pin, lock. Unlock, index, slide it up on the pin, lock. Very, very simple. Guess my accuracy will be as good as my accuracy when I laid out the wheels, the index plates, and you know they look good from here, so I guess they're all right. Bearing clearance, 5/7,000 bearing clearance in there is plenty. I think this bearing here ended up with about 4 or 6 thousandths clearance. This one, before I took the 20 thou out of it, it had about 7 thousandths clearance. So the bearing clearance is fine. It goes back and forth just right, and it does not, even with it not locked down, it doesn't have a whole lot of give or flop to it. So that'll do it for this video. I hope y'all enjoyed. I hope you learned something. I hope maybe you got inspired to go build one for your own self. Y'all drive safe. Watch for deer.